Isomerism in organic chemistry is an important area which tell us about the existence of compounds with a similar molecular formula but different structural and functional orientation. Most of the time we encounter different organic compounds which have same molecular formula but they have different structural and functional orientation. So such compound are known as isomers, and as a whole the phenomena is known as isomerism. Here we have two types of isomerism, especially constitutional isomerism and stereoisomerism. In this segment we will focus on constitutional isomerism. Basically, constitutional isomerism tell us about the type of isomerism in which the connectivity of atom is different. And we will discuss constitutional isomerism with respect to following 5 different examples. So let us first focus on the first example. In first example we have two molecules. One is N-butane and another is isobutane. Both are alkane. They have same molecular formula of C4H10, but they have different chain, they have different structure. So such type of isomerism is known as chain or structural isomerism. The next example, we have two molecules, one bromopropane and two bromopropane. We have a same functional group of bromine alkyl. They are alkyl halides. In one case, in one bromopropane, the bromine atom attached to the one end of the carbon chain, and in another case we have the bromine attached to the central carbon atom. So their position is different. So such type of isomerism in which the functional group is same but their position is different, so such type of isomerism is known as positional isomerism. Similarly, the third type of isomerism which has the same molecular formula but they have different functional group, such as the first example. In this case it's ether. We have oxygen atoms which one methyl and another ethyl group are attached, so such functionality reflect ether. Its name is ethyl methyl ether, and another molecule is a propanol. So it has alcoholic group. So they have different functional group but same molecular formula. So such type of isomerism is known as functional group isomerism. The fourth example which tell us about the connectivity of different alkyl group to same multivalent atom. We have oxygen. Just for example, in case of ether, in ether we have a different alkyl group attached to oxygen atom. So oxygen is divalent. It can be a nitrogen which is trivalent. So both nitrogen and oxygen are multivalent atom. So such type of isomerism in which the multivalent atom is linked to different alkyl group is known as metamerism. So this is an example of metamerism. This is Metamerism in first case is just diethyl ether, the oxygen is attached to two alkyl group which are ethyl, and the second example, one is methyl and another is propyl. Both have same molecular formula but different alkyl group are attached to oxygen atoms. Such type of isomerism known as metamerism. And the last category reflect a type of isomerism which form by a movement of proton along with the corresponding adjustment of the double bond is known as tautomerism. So the last example is tautomerism. One is keto form, which is ketone, and another is enol form, in which there is alcoholic moiety and double bonds of such type of functionality is known as enol form. So all these five different examples are known as constitutional isomerism, whether there is a chain of structure isomerism, positional isomerism, functional group isomerism, metamerism, or tautomerism. So all these are examples of constitutional isomerism, which are a type of isomerism in which the connectivity of atom is different. So in all these five cases, the connectivity of atom is different. Now let us focus on stereoisomerism, which can be further divided into two different categories. One is known as configuration, in which the configuration is different along the double bond, or they are non-superposable, and another category is known as conformational isomerism. So first focus on configurational isomerism, which is further divided into two different types. One is geometric isomers and another is optical isomers. Here we have two different examples. Both are two butene molecules, but in one case the two bulky groups are on the opposite side, and in another case the two bulky groups such as methyl are on the same side. So such type of geometric isomers are known as cis-trans isomers. The first example is trans 2-butene, and this is known as cis-2-butene. When the two bulky groups on the carbon of the double bond are on the same side, so such isomer is known as cis, and when they are on the opposite side, so such isomer is known as trans isomers. So both are examples of geometric isomers which are formed across the double bond, in which each carbon of the double bond has at least two different groups. So such type of geometric isomerism also known as cis-trans isomerism. As far as optical isomerism is concerned, so optical isomerism, again, when we are talking about stereoisomerism, so in stereoisomerism the connectivity is same. In stereoisomerism connectivity is same, but the orientation is different in three-dimensional space. Here we have a molecule, methyl group, and we place a mirror in between, and then the structure or the mirror image of the molecule will be like this one. So such type of isomers which are mirror image of each other, so they are known as stereo, or they are known as enantiomers. This is mirror, so both are non-superposable mirror image of each other, so such type of isomers are known as enantiomers. which is an example of optical isomerism. So optical isomerism show a different behavior toward plane polarized light. Either it bends the light toward the right direction or left direction. It can be dextro-rotatory or levo-rotatory. So this is an example of optical isomerism. And as far as the conformational isomers are concerned, they are formed as a result of rotation across the carbon-carbon single bond. Here we have ethane molecule, and we try to rotate one of the methyl group across single bond, and we get structure like so. Both are two different isomers which are formed when we rotate one of the methyl group. In one case, the two hydrogens are face to face each other, they are eclipsed, but in another case the two hydrogens are on the opposite side, which we compare a bit earlier. So such type of isomerism is known as conformational, and each isomer is known as conformal. So I hope you got a clear understanding about isomerism in organic chemistry.